It's just a land of extreme everything.
And he said, son, start praying. And I did.
California likes to call itself the earthquake capital of the country, but they're not even close. This is earthquake central.
Thermal imaging shows something is moving beneath Oregon's crust. The magma chamber beneath the Cascade Range is heating up, and fast. Could this be the spark that ignites a chain reaction across the entire West Coast? Let's dive into what scientists are discovering right now and why some experts are alarmed. The silent shift beneath Oregon, home to mist-drenched coasts, towering forests, and peaceful volcanic peaks, may soon be at the center of a geological awakening, unlike anything in modern memory. Far beneath the Cascades, a vast and mysterious force is stirring, and the data is becoming impossible to ignore. In early 2025, satellite-based thermal sensors from NASA and the European Space Agency began to record sharp, accelerating increases in crustal heat beneath the Three Sisters volcanic complex in central Oregon. What began as a subtle fluctuation in thermal output soon evolved into a full-blown geothermal surge, radiating through 90 kilometers of bedrock. This wasn't ordinary geothermal activity. This was a deep pulse, a wave of energy rising from the depths of Earth's upper mantle, sourced not from weathered vents or known hydrothermal system, but from magma itself. Magnetotelluric surveys and satellite INSAR data revealed the heat source originated from 10 to 15 kilometers below ground, a depth consistent with pressurized magma chamber. Even more chilling was the expansion pattern. The heat didn't stay confined to Three Sisters. It spread, radiating north toward Mount Hood and south toward Crater Lake, aligning with dormant fault systems and long, quiet volcanic zones. Was this a fluke, a flaring geothermal pulse, or was it something far more dangerous? Global volcanologists quickly recognized the signature. It mirrored the pre-eruptive heat patterns observed before the explosive awakening of Chile's Laguna del Mal and Italy's Campi Flegrei, two of the most dangerous caldera systems on Earth. The implications were staggering. Could this be the moment the Cascade magmatic corridor reawakened? Could multiple volcanoes be sinking, drawing from a single rising force? Or has this system been quietly building pressure for decades, waiting for just the right tectonic trigger? According to one USGS researcher, what we're seeing beneath Oregon isn't isolated, it's systematic. This isn't just a hotspot. This is a corridor showing signs of ignition. And if they're right, the next eruption in the Pacific Northwest may not come from one mountain. It may come from all of them. The magma moves. It began like a heartbeat, soft, rhythmic, nearly imperceptible, but beneath the wilderness of Central Oregon, that beat is growing louder. In early 2025, seismic arrays stretching across the high Cascades registered a sequence of harmonic tremors, low-frequency vibrations from 10 to 15 kilometers below the surface. These were no ordinary quakes. These were the tremors of magma on the move, rising through the Earth's fractured crust like blood through ancient veins. Thermal satellites from NASA and ESA confirmed the unsettling trend. What began as a local heating event beneath the Three Sisters volcano rapidly expanded. Within 21 days, the geothermal signature grew into a 150-kilometer corridor of rising heat. The warming advanced northward toward Mount Hood and southward to the caldera of Crater Lake, forming a contiguous thermal path, a molten vein pulsing through the Pacific Northwest. This wasn't just volcanic warming, it was structural transformation. Magnetotelluric scans revealed a partially molten conduit stretching the full length of the high Cascade. In places, over 25% of the crust was in a molten or semi-molten state, pressurized, restless, and deforming its surroundings. Simultaneously, INSAR satellite data recorded uplift at multiple sites. Each zone, from South Sister to Broken Top to Mount Washington, was rising by 3 to 6 millimeters per month. The geochemistry told an even deeper story. Volcanic gases rich in carbon dioxide and sulfur dioxide have long been used as indicators of active magmatic system, but recent samples collected near South Sister contained helium-3, a rare isotope typically only seen in regions of direct mantle upwelling. That suggests that the system may be more than just a surface-level magmatic body. It could be tapping directly into the Earth's deeper interior. Petrological analysis of xenoliths, chunks of mantle rock ejected during older eruptions, has revealed patterns of remelting and high-pressure crystallization consistent with fresh injections of hot magma. In other words, something new is intruding, and it's forcing older rock to adapt or melt. Additionally, new gravimetric surveys show subtle mass deficits along the corridor, areas where denser rock has seemingly vanished. This supports the theory that large pockets of melt now occupy that space, expanding and displacing the surrounding crust. Seismologists now believe we're witnessing the activation of a transcrustal magmatic corridor, one capable of linking multiple volcanoes into a single dynamic system. Could pressure in one section rupture another 100 kilometers away? Could the system behave not as separate volcanoes, but as one superstructure? Some geophysicists believe the corridor could trigger a cascade of eruptions. If one node fails, others may follow. And if Oregon is merely the middle of this corridor, not the beginning or end, then Mount Shasta to the south and Mount Rainier to the north may already be feeling the pulse. One volcanologist's warning echoes like a prophecy. This is no local disturbance. This is a deep, unified breath from the Earth itself, and its exhale could shake the continent. The chain reaction. What if the tremors in Oregon aren't an isolated warning, but a prelude to a continental shift? Scientists are now reevaluating the entire Cascade volcanic arc through a new, unsettling lens, not as disconnected peaks, but as a single, interlinked volcanic entity, a 1,200-kilometer geologic beast that stretches from Mount Shasta in Northern California through Oregon's mountainous core, reaching all the way to British Columbia. This isn't just a line of volcanoes, it's a corridor of latent energy, quietly straining beneath North America's surface. The question haunting geophysicists now is simple, yet terrifying. What happens when pressure in one chamber destabilizes the next? The 2010 Eyjafjallajökull eruption in Iceland taught us that chain reactions are very real. Its blast was followed by rising tremors and awakening signals in the Katla system nearby. Prompted by underground shifts in pressure, the parallels are growing. In April 2025, harmonic tremors not only surged in Oregon, they were faintly echoed beneath Mount Rainier and Mount Baker, hundreds of kilometers to the north. Could we be witnessing a similar domino effect unfolding here? The volcanic rooms of the Cascades are closer than we think. In some regions, magma chambers lie just 10 to 15 kilometers apart. If one overpressurizes and ruptures, the shock wave of energy could bleed into neighboring systems, setting off a volcanic relay across multiple peaks. But that's only half the story. The Cascade Corridor intersects major fault zones like the San Andreas and the Mendocino Triple Junction. If magma destabilization ripples into these tectonic systems, we could be facing not just volcanic eruptions, but earthquakes, landslides, and tsunamis. Even more concerning is the role of hydrothermal systems, natural pockets of superheated water trapped within fractured rock. A sudden magma intrusion could flash these systems into steam, causing explosive hydrothermal eruptions with almost no warning. Recent data from USGS thermal wells show rapidly increasing subsurface pressure zones along older calderas, including the Goat Rocks area and regions east of Mount Adams. These pressure increases aren't linear, they're accelerating. The signature resembles pre-blast pattern observed in other volcanic fields, where magma intruded into water-saturated crust. Satellite interferometry has also detected a curious eastward bulging of the crust along the Oregon-Idaho border, something that hasn't been seen in over a decade. Combined with faint harmonic tremors, the signs suggest that magma may be migrating eastward, using ancient rift faults as pathways. Computer models from institutions like the Pacific Northwest Seismic Network simulate scenarios in which activity at one volcano, such as South Sister, leads to destabilization of others over weeks or even days. These simulations often end the same way, a chain reaction, too rapid to fully contain. New insights from geodynamic modeling at Stanford University reveal that the Cascadia subduction zone, a massive boundary where the Juan de Fuca plate sinks beneath the North American plate, isn't just influencing seismic behavior, it's acting as a conveyor belt for magma pressure. The models show that stresses caused by slow slip events deep in the subduction zone can alter magma buoyancy across hundreds of kilometers. This means that tremors in southern Oregon may trigger melt movement as far north as British Columbia or far south toward Northern California. These simulations also underscore the importance of long-forgotten fault system. Paleoseismic trenching in southern Washington and central Oregon has uncovered evidence of prehistoric eruptions linked to fault reactivation, eruptions that may have occurred as secondary effects following tectonic shifts hundreds of kilometers away. This historical precedent reinforces the theory that the Cascade, while volcanically segmented at the surface, may be connected beneath by a shared mantle source, acting like a subterranean neural network of fire. Additionally, crustal tomography scans released in late April 2025 by a joint USGS-UNAVCO study unveiled a mid-crustal melt layer, a 10 to 20 kilometer thick band of low-density rock extending from Mount Shasta all the way past Mount Rainier. This layer, saturated with volatiles and partially molten material, could serve as the perfect transmission medium for thermal and pressure impulses. One of the most disturbing hypotheses now gaining traction is the concept of pressure harmonics, rhythmic fluctuations in melt movement that resonate through the corridor like sound waves in a pipe organ. These could build synchronously, amplifying until multiple chambers rupture in rapid succession. It's the geological equivalent of a coordinated volcanic crescendo. So the question isn't just, will Oregon erupt? It's, will it pull the rest of the West Coast with it? This isn't a regional event anymore. This is a loaded gun running down the spine of the continent, and the trigger may already be halfway pulled. Signs from below the surface may be calm, but the signals beneath it are screaming louder by the day. Gas sensors near South Sister and Broken Top, two of Oregon's most closely watched volcanic peaks, have recorded a troubling surge in emissions. Carbon dioxide, sulfur dioxide, hydrogen sulfide, all are rising. These aren't surface pollutants. These are the silent breath of magma, pushing upward, escaping through fractured rock and ancient fault lines. But that's not the only sign. Geochemical analysis of groundwater samples near Bend and the Mackenzie River corridor now shows significant thermal anomalies. Water temperatures have climbed by nearly 5 degrees Celsius in some regions over baseline readings taken just 2 years ago. Local landowners are reporting new warm springs bubbling through forest floors where there were none before. In at least one case, fish kills were observed in a remote tributary, likely due to dissolved volcanic gases or sudden heat exposure. Meanwhile, GPS arrays deployed across the high Cascades have detected uniform uplift, subtle, yes, but steady, between 3 and 8 millimeters per month. In geologic terms, that's not just movement, that's pressure, building, pulsing, shifting, and it's not limited to one site. The uplift is radiating outward in a bullseye pattern, suggestive of a pressurized body expanding from below. Magnetotelluric scans support this. Beneath South Sister, beneath Broken Top, and now beneath the edges of Mount Washington and Belknap Crater, resistivity readings are dropping. These areas are becoming more electrically conductive, a textbook sign of fluid, molten material saturating the crust. Is this magma slowly infiltrating an older, dormant system? Is the corridor breathing, stretching toward other volcanoes, once considered extinct? And if so, what's next? One seismologist summed it up with a stark metaphor. It's like watching a balloon inflate beneath a sheet of glass. You can't see the balloon, but you can watch the sheet rise, and you know, eventually, something gives. The Earth is flexing, and this time, the pressure may not stay silent for long. Why this matters now. Over 1.5 million people live in Oregon's volcanic impact zones, many of them with no idea that a molten threat could be building beneath their feet. Cities like Bend, Eugene, Redmond, and even the edges of Portland lie within potential disaster radii, surrounded by peaks that haven't erupted in centuries, but may now be stirring. But the threat isn't just lava, it's what comes when fire meets ice. The real danger here is lahar, volcanic mud flows capable of destroying everything in their path. If magma were to breach near the Three Sisters or Broken Top, it could melt entire glaciers in minutes. That meltwater would mix with ash and earth, forming concrete-like rivers of mud, surging at up to 60 miles per hour. These lahars don't just flood, they obliterate homes, roads, schools, everything. And with the steep elevation and glacial coverage of the Cascades, Oregon is primed for exactly this kind of event. Worse still, air travel across the western United States could grind to a halt. Volcanic ash is fatal to jet engines. Ash plumes reaching the stratosphere could force airport closures from San Francisco to Seattle, creating cascading disruptions to national and international logistics. Power lines would spark and burn. Volcanic lightning, electrical storms inside ash clouds could ignite wildfires in already parched regions. River systems, especially the Deschutes and Willamette, could be contaminated by acidic runoff and toxic sediments for years, endangering ecosystems and drinking water supplies. And unlike earthquakes, there may be no sudden shock to announce this disaster, just a rising temperature, a subtle tremor, and then chaos. All it would take is one breach in the crust, one deep pocket of magma finally punching through. And the ripple effects wouldn't stop in Oregon. They'd spread north into Washington, south into California, and far beyond the region's borders, through the skies, the economy, and the nation's sense of safety. This isn't science fiction. It's the risk that scientists are modeling right now, day by day, sensor by sensor. And what they're seeing has them more concerned than ever before. Are we ready? The U.S. Geological Survey has increased monitoring efforts in Central Oregon, but even with thermal drones, real-time GPS arrays, and expanded seismic networks, the region remains disturbingly underobserved. Why? Because Oregon's most dangerous volcanoes are also its quietest. The Three Sisters, Mount Jefferson, and Mount Washington haven't erupted in recorded history. Some haven't shown surface activity in thousands of years. That geological silence has lulled local communities and agencies into a false sense of security. But now, with tremors beneath their roots and heat rising from their cores, they may not be sleeping giants. They may be unmonitored threats on the brink of reawakening. Many of these peaks still lack real-time sensors. Whole swaths of the Cascade Range remain blind zones, where signals of magma movement could go undetected for days, even weeks. And in volcanic crises, time isn't a luxury, it's a lifesaver. Worse, the state's emergency planning still focuses largely on isolated eruptions, one volcano at a time. But what if multiple peaks respond in unison? What if the entire corridor ignites like dominoes tipped by a single subterranean push? New simulation models from Oregon State University show that a corridor-wide eruption event, even a moderate one, could displace over 250,000 people. Portland's drinking water, sourced in part from Mount Hood's watershed, could be threatened. Economic loss could stretch into the hundreds of billions. Are we truly prepared for that? Or are we still clinging to outdated maps, hoping ancient mountains will remain silent just a little longer? The ground is changing, and if we aren't listening, the earth won't whisper forever, it will roar. The final question: the ground beneath Oregon is bubbling, heat is rising, and scientists are asking a question no one wants to say out loud. If this corridor erupts, where will it end? What if Oregon isn't the beginning or the end, but the middle of a volcanic chain reaction? The West Coast has lived in the shadow of its volcanoes for centuries, but now that shadow may be moving. USGS models point to a broader pattern. Pressure may be spreading from Oregon toward Washington and Northern California, along fault line and old volcanic scars. Thermal signals have spiked in quiet zones like Medicine Lake and Mount Baker. If Oregon is a central node in a shared magma corridor, releasing pressure here could shift it elsewhere. Some models suggest a rupture in one zone could trigger others within days. And the risk isn't just lava. Sudden steam explosion, fueled by underground water, could strike without warning. Gravimetric readings show rock displacement along the Oregon-Nevada border, likely from rising melt. The cost of multiple eruptions would be staggering. Flights grounded, crops ruined, power grids hit, cities displaced. Emergency planners now warn of a worst-case scenario: continental cascade failure, a domino chain of collapse in land, systems, and lives. We're not just talking magma anymore. We're asking if the West Coast can hold geologically, socially, economically, and if we've waited too long. Like this video if you want real-time updates on Pacific Northwest volcanoes. Subscribe for the latest geological discoveries and alerts. Let us know in the comments. Is this a local event or a warning for the entire coast? Thanks for watching, and remember, beneath our feet, the Earth is always moving.